Assalamu alaikum and greetings. We bid to our respective lecturer, Madam Nur Hanani Binti Azami. My name is Alani Fatini Binti Muhammad Zamri, DC 97592, and also my friends over here, Sarah Hani Binti Muhammad Azral, DC 97696, Aimi Afifah Binti Muhammad Husni, DC 97661, and also Waheedatul Nazeerah Binti Kamaruddin, DC 97689. We are from Quad Squad and we will be presenting the topic sets. I will start with the introduction to this topic of sets. What is a set? Well, simply put, it's a collection. First, we specify a common property among things, and then we gather up all the things that have this common property. For example, the items you wear, such as hat, shirt, jacket, pants, tops, or bottoms, and so on. I'm sure you could come up with at least 100 of those. This is known as a set. Or another example is types of fingers. This set includes index finger, middle finger, ring finger, and pinky finger. It is just things grouped together with a certain property in common. Why is set important? Sets are the fundamentals property of mathematics. Now, as a word of warning, sets by themselves seem pretty pointless. But it's only when we apply sets in different situations do they become powerful building block of mathematics that they are. And for that, let's check some everyday life examples of sets. The first one is in the kitchen. Kitchen is the most relevant example of set. Our mother always keeps the kitchen well arranged. The plates are kept separate from bowls and cups. Sets of similar utensils are kept separately. The second example is school bags. School bags of children is also an example. There are usually divisions in the school bags where the sets of notebooks and textbooks are kept separately. Next is the shopping malls. When we go shopping in a mall, we all have noticed that there are separate portions for each kind of things. For instance, clothing shops are on another floor, whereas the food court is in another part of the mall.
Hi, my name is Sarah Hani Binti Muhammad Azral, ID DC 97696. Our main objectives are to explain and demonstrate about the types of set, which I will explain later, and the operation of set. Basically, what does operation of set consists are union, intersection, complement or difference, and symmetric difference, which are our main subtopics that we will be covering.
Union. Before I continue with some example of union, you need to know what is union. Firstly, you must know that the symbol of union looks a little bit like capital letter U and it can be read as the word OR. Union is a set consisting of all elements that belong to A or B and denoted by A union B. Means that if set A and set B have element in common, then this element will be a member of both sets and is only included once in the union. This relation and operation can be visualized graphically by using Venn diagram. For example, there is two circles of set A and set B. If set A contains the elements 1, 2, 3, and 4, and then set B contains the element 2, 3, 5, and 6, then the elements which are member of A or B are 1, 2, 3, 4, 5, and 6. So this union form a new set that containing the element of 1, 2, 3, 4, 5, and 6. You need to know because of set A and set B have the same element which is 2 and 3. So the set must overlap each other in Venn diagram. And the element of 2 and 3 must be in this area. The most important thing is even though 2 and 3 are member of both set A and B, but 2 and 3 are only listed once when we write the union. Intersection. Intersection is a set consisting of all elements that belong to both set A and B and denoted by A intersect B. The symbol of intersection is look like an inverted U, like this, and this can be read as the word and. Now we move on for example 1. By using a Venn diagram, there is a set A contains an element A, B, C, and D, and set B contains an elements B, C, E, and F. Looking at these both sets, we will find intersection of A intersect B. If you can see that B and C are common to both sets, so you must draw a set that will be overlap to each other. Why they must be overlap? Because in this both set A and B, there is some common element to each of them. To find an intersect of A intersect B, you just write the element in this overlapping region, which is the answer of A intersect B is B and C. This means when you draw the Venn diagram correctly, intersection can be found out within a few seconds.
The next subtopic is complement or difference. There's a special way of saying everything that is not, and it is called complement. By using the variable and as, we show it by writing, which means everything that is not in as, like this. You can also subtract one set from another. For example, taking soccer and subtracting tennis means people that play soccer but not tennis, which is Alex and Hunter. And this is how we write it. In a Venn diagram, this is how we show it.
Hi, we meet again. So, I will be covering about a symmetric difference. So, what is symmetric difference? Like any other operation, a symmetric difference also happens between two sets. Suppose we have two sets A and B. Their symmetric difference would consist of all elements present in either A or B, but not in the intersection of A and B. When representing the symmetric difference between any two sets, let us assume set A and set B are denoted by the symbol of this triangle shape. As we call it as an increment symbol. Let's take a look at the example given set A, which is 2, 6, 7, and 9, and set B, which consists of 2, 4, 6, and 10. From the definition provided above, we know that symmetric difference is a set containing elements either in A or B, but not in both. We look for elements common in A and B. These two elements are 2 and 6. A new set would contain all the remaining elements, which are A increment to B equals to 4, 7, 9, and 10. Next is the types of set, which includes element, subset, power set, empty or null, universal, disjoint, and cardinality.
The first subtopic for the topic set is element. There is a fairly simple notation for set. We simply list each element or member separated by a comma, and then we put some curly brackets around the whole thing. For information, element or member mean the same thing, okay? This is the notation for the previous example. As you can notice, the first example has the ... the three dots together. The three dots are called an ellipsis and mean continue on. So that means the first example continues on for infinity. Okay, there isn't really an infinite amount of things you could wear, but I'm not entirely sure about that. After an hour of thinking of different things, I'm still not sure. So let's just say it is infinite for this example, okay? So, for the first set, socks, shoes, watches, shirt, we call an infinite set. And the second set, index, middle, ring, pinky, we call it a finite set. But sometimes the ellipsis can be used in the middle to save writing long list. For example, the set of letters A, B, C, ... X, Y, Z. In this case, it is a finite set. Yeah, of course. There's only 26 letters in the alphabet anyway, right?
Disjoint and empty set or null sets. Let's say that we have two sets A and B. Drawing the set that they don't overlap. This is to show that the two offset contains elements that are completely different from each other. In this case, we say that the two sets are disjoint. What is disjoint? Disjoint sets have no element in common, but if both of sets overlap, this indicates that they are one or more elements common to each other. If two disjoint sets have no element in common, we call it as an empty set or null set. The symbol used to represent an empty set is curly bracket or /0.
Subset. A set B is a superset of another set if all elements of set A are elements of set B. Since B contains element not in A, we can say that B is a superset of A. The superset relationship is denoted with four symbols. First, subset of. These symbols are used to say a set is a subset of another set. Second, not subset of. This symbol is used to say a set is not a subset of another set. Third, subset of. These symbols tells us that the second element is a proper subset of the first. And the fourth one, not subset of. This symbol tells us the second element is not a proper subset of the first. Example for subset. Example 1. Given set A and set B, what is the relationship between these sets? We can say that A is a subset of B since every element of A is also in B. This statement is denoted by the symbol A is a subset of B. Example 2. Given set P and set Q, what is the relationship between this set? We can say that P is not a subset of Q since not every element of P is contained in Q. For example, we can see that 1 is not an element of Q. This is denoted by P is not a subset of Q. Power set. The power set of a set A is defined as the set of all subsets of the set A, including the set itself and the null set. If A is a set, then the set of all subsets of set A is called the power set of set A, which is denoted by PA. Basically, this set is a set that contains all its subsets as its elements. Example, given set A, which is A, B, C. So the power set of A is null set A, set B, set C, set AB, set BC, set AC, and set ABC. The power set A contains 8 subsets in this set, which is denoted by PA equal to 8. Universal set. A universal set, usually denoted by U, is a set which has elements of all the related sets without any repetition of elements. Example, if P and Q are two sets, such as set P, which is 3, 6, 9, and set Q, which is 2, 4, 6, 8, then the universal set associated with these two sets is given by set U, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9.
Next, we have cardinality. The cardinality of set is a measure of set size, meaning the number of elements in the set. The cardinality of set is denoted by the vertical bars like absolute value signs. For instance, for set A, its cardinality is denoted by A modulus. Let's take a look at the example. Remember that order doesn't matter and duplicates doesn't count. These sets are all equal, where the set of 7, 8, 9 is equal to 9, 8, 7, or 7, 7, 8, 8, 9, 9, or 7, 9, 8, 7, 7, 8. We only care about one thing, and it is a value in its set or not. Second example is each set has a certain number of distinct elements and it is cardinality. For example, the set 7, 8, 9 has cardinality 3. Cardinality is written with vertical bars around the set like this. So here's the third example where the modulus set 7, 7, 8, 8, 9, 9, which only consists of 3 because the three numbers is repeated 2 times even though it has 6 numbers. Also, which is the cardinality of set in set of 1, 2, 3 and 4, 5, 6, which equals to 2. Why? Because we have 2 bracket symbol at the end and at the first. So it only counts as one element. Up next is the number of sets. So here are the definitions of the type of number. First, we have natural numbers, which is the common counting numbers. Next is prime number, which is the natural number greater than 1, which has only 1 and itself as factors. Third, composite number, a natural number greater than 1 which has more factors than 1 and itself. Next is whole numbers, the set of natural numbers with the number of 0 adjoined. Integers, whole numbers with their opposites, which is the negative numbers, adjoined. Rational numbers, all numbers which can be written as fractions. Next, irrational numbers, all numbers which cannot be written as fractions. Real numbers, the set of rational numbers with the set of irrational numbers adjoined. The last one is complex number, a number which can be written in the form of a plus bi, where a and b are real numbers, where I is the square root of -1. So what does all this look like? So let's take a look at the example shown here. The natural numbers, which is denoted by the capital letter of n, consists of 1, 2, 3, 4 and so on. Next, prime numbers, which is denoted by the symbol of capital letter P, consists of 2, 3, 5, 7, 11, 13, 17 and so on. Next is composite number, consists of 4, 6, 8, 9, 10, 12 and so on. Next is whole numbers, which is denoted by the capital letter of W, which starts with 0, 1, 2, 3, 4 and so on. Integers, which is denoted by the symbol of capital letter Z, which consists of negative numbers and positive numbers, start off with -3, -2, -1, 0, 1, 2, 3 and so on. Next is rational numbers, which is denoted by the symbol of capital letter of Q, which consists of -1/2, 0.333, 5/2 and 11/10 and so on. Next is irrational numbers, which is denoted by the capital letter of F, which consists of pi, square root 2, 0.122122 and so on. Real numbers, which is denoted by the capital letter of R, which can be start with negative numbers. For example, -3, -1, 0, 1, 15, 1.1, square root 2, 2, 3, pi, and so on. Next is complex number, which is the last one. So complex number is denoted by the capital letter of C, which is contain such as -3 plus 2 plus 2i, 0, 1 plus 3i and so on. So that covers all the subtopic, and thank you for watching. Bye.